Hello, everyone. Thank you for joining me in this first session on Introduction to Quantum Technology. My name is Madi Hosseini. I'm a faculty of Electrical and Computer Engineering at Purdue University. Today, I'm going to go over some of the main topics that we will cover in this course, and then we'll describe some of the applications that we will cover and some of the ways that we will assess the learning outcome and learning objectives of this course. And based on this introduction, then we will start in the next few videos, next 3 videos. I will go over some videos, some lectures trying to identify the motivation and the applications of various quantum technology that we would go through. In this course, I split the topics into 3 main topics. In the first part of the course, we will describe fundamentals of quantum mechanics. In that part, we will introduce, for example, postulates of quantum mechanics, such as wave-particle duality. We'll talk about entanglement, uncertainty principle, coherence, and try to build a mathematical ground for introducing some of the more complex quantum mechanical phenomena. In the second part of the course, we will talk about quantum resources. By quantum resources, I mean the type of quantum entities that we will use to build quantum technologies out of. For example, we use atoms, we use ions, we use superconducting circuits, and use photons to build quantum technologies, various quantum technologies. So these kind of resources would be introduced in the second part of the course. And in the last part of the course, we will go over various quantum technologies, such as quantum sensing, quantum communication, and quantum computation, based on the quantum resources, and we will see how various technologies can be built using these quantum resources. There are various quantum technologies that we will cover in this course. One of the main drive for quantum technology is the need for having better and faster faster computers. Therefore, quantum computers has been one of the main applications of quantum mechanics and quantum technology, and there has been various platforms that being developed as a result of this. For example, IBM and Google are developing superconducting quantum computers, and also atomic platforms are being used to develop processors, and this is another topic that we will cover in this course. Photonic is another topic that we'll cover, which has application both for information processing as well as communication. In terms of communication, quantum communication is another important application of quantum technologies, where you can securely communicate between 2 parties. And this is done using light that carries quantum information, and it turns out that laws of quantum mechanics allows you to securely communicate between 2 parties and be sure that no one can hack your information. And another topic, another application that we will cover in this course is quantum sensing. And this refers to measuring some quantities with very high precision that has application both in fundamental science and also industry. There are many different companies which pursue developing quantum technologies, and here you see a partial list of that, but there are more than 100 companies who work for different aspects to develop different aspects of quantum technologies. This ranges from developing superconducting circuits, miniaturizing atomic systems, nanofabricating photonic structures, and also atomic structures. And different technologies uses various platforms and various materials to develop the technology. And we will discuss these different materials and advantages and disadvantages of different materials. As an example, one of the goals of this course is to introduce engineering challenges in various technologies. For example, to build a quantum computer, you need to build a processor that is compact, that possesses very small amount of noise, interference, and can be able to be integrated with the algorithm layer such that we can have efficient connection and connectivity between various elements inside our computer. And also, the low power consumption is another issue that we need to resolve. And overall, there are various issues that we need to deal, various engineering challenges that somewhat are different from what we are used to in classical processors. And we need to carefully engineer and design the system such that we can make enough number of quantum transistors to build a useful quantum computers. To understand the challenges involved in building a quantum computer, for example, or a quantum communication system, first we need to understand what are the governing principles of such a processor. What do we mean by decoherence? What do we mean by noise? What do we mean by loss? And what do we mean by quantum algorithm? And by understanding these concepts and also building mathematical ground, we can try to mathematically describe some of these phenomena, some of these challenges, and then after that we'll talk about how someone can build such a processor and what are the engineering challenges and how we can address those engineering challenges. So as a result, in this course, I divided the topics of this course into three main sections, as I described earlier. In the first part, we talk about fundamentals of quantum mechanics. So even if you do not have a solid background in quantum mechanics, in the first part of the course, we try to provide that background and talk about how quantum mechanics got started, what are different important concepts that we will use to explain some of the quantum technologies. And this includes the wave-particle duality, the light-atom interaction, the Hamiltonian, the Heisenberg uncertainty principle, entanglement and noise, and so on and so forth. In the second part, as I mentioned, we talk about quantum resources, the photons, atoms, superconducting computing, ions, superconducting circuits, ions, and we see how various entities could interact with each other, for example, through interaction with electromagnetic field. Lastly, we will talk about application. Application includes sensing, communication, and computation, and we will see how these quantum resources can be used, put together to develop a new and novel application that could revolutionize the way we do things today. The learning objectives of this course are listed here. In short, by the end of this course, you will be able to identify fundamental differences between a classical system, a classical technology, and a quantum technology. You will be able to mathematically describe some simple quantum mechanical phenomena and identify various platforms and various materials that are used to build quantum technologies. By the end of this course, you will also be able to interpret some of the signatures, quantum signatures in experimental data and experimental systems, and also analyze engineering challenges in quantum technologies and have some ideas how to address those engineering challenges. There are various assessments that we consider in this course. In general, we have 4 different kinds of assessment, and the final grade is equally divided between 4 different assessments. In one part, we do have homework, and homework consists of a multiple choice question and sometimes problem solving. The multiple choice question is a type that you will go online on edX platform and try to answer the questions, and the system will grade it itself. If you do have any question regarding these multiple choice questions or problem solving questions, you can post it at the end of the section in the Q&A section, and then we try to discuss it as a group. And also, we do have reading assignment and discussion. Typically, for every module, we do have 2, 3, 4 discussion sessions where we provide some reading assignment. You go and read and come to the discussion session, provide your own question and your own opinion about some of the other questions posted on discussion. We do have quizzes, in general, in total 2 quizzes for part 1 and part 2 of this course. And for part 3, we do have a project. And the final project, you decide what quantum technology you want to study in depth. You pick the topic and you identify 5 different things that you need to elaborate. And this elaboration could be in a form of an essay or in a form of a presentation. The type of things that we like to see as an outcome of the final project is motivation and introduction to the particular platform that you consider, the basic working principle of that platform and how it can be implemented, the engineering challenges of that platform, and also ways to address those engineering challenges. So whether it's a report or a presentation, it should include these 5 points, and that would constitute the final project. That brings me to the end of this video. We discussed the overall outline of this course, and the next few videos we will talk about how to integrate various technologies and what is the motivation of this course to introduce various technologies. Thank you for your attention, and I'll see you in this next class.